I guess maybe we can somewhat get started in any case. Okay, so what I thought I'd try doing live today is implement like the optional support in our cell interpreter. So last time what we did is we worked on getting support for opaque values merged in. So now we have an opaque type that we can use to back our own optional type, which by the way, optional, right? So if we go check the, well, actually let's first try and do something here. So this is our cell playground. So let's recap, right? So what we care about is this notation, right? So if we run this, sorry, am I doing this wrong? It's this notation. Run, right? So this says 500. So this actually returns not the 500 integer, but it does return a optional value, right? So we can prove this because if I make this, is this equal to 500, right? This doesn't succeed because as you can see, there is no matching overload for equal to be applied to an int. So that doesn't work. So how do we solve that? We solve that by robbing this inside an optional. So that's one way of solving that. So if we run this now, this evaluates to true. We'll look into really what this means. That's actually the right-hand side of the operator, of the equal operator. This stuff here is the first thing I want to try to implement. It'll come with a few challenges. We'll look into them in a sec, but let's not focus on those right now. So what we want is be able to return like an optional type of A500, right? So this now succeeds. So that obviously is not how this is supposed to be used. The way you're supposed to, that you would use that, let's say if the balance of my account, if the field balance doesn't exist in my account struct, then I want it to be 0, right? So I don't know if it's there, and then or 0, and then let's say, is it more than 100? So this is now going to, well, yeah, you don't see it, but it does return true in this case, right? So I can actually get rid of this, run this, right? And I get 500 back. Now, if I remove the balance field, or in this case, just rename it, right? And run this is going to return 0. So now I can do things in a nicer way than if I would have to do something like this. Has account.balance, i.e. does that field exist? In which case, return the value of that field, otherwise return 0, right? So if I run this is going to return 0 again, but if I make it so that the field exists, I get 500 back, right? So obviously this is not nice. This is much nicer. Account dot, maybe there is a balance, maybe there isn't one. In case there isn't one, we return the value 0, and then we want to make sure that it's more than 100 in this case. So I run this, and this is true. If the balance field isn't there, it returns false. All right, so that's more or less what we're trying to implement. I need to check like exactly what are all the, so just to recap, right? So we merged opaque type. Opaque type is actually what the Go implementation uses for its optional type, right? So you can see optional type is a new opaque type optional. And then an opaque type is, as the name implies, is opaque. We don't know what's in there. So now the trick is to go and sorry, checking my brightness of my monitor. It's a beautiful sunny day here in Quebec today. Really cold though. We have a minus 16 Celsius right now. And yeah, and I get a bunch of reflection on my monitor. But anyways, let's go with that. Yeah, so back to what we're saying here. So we have an optional type, new opaque type. And again, as I say, an optional type is an opaque type is opaque, so you don't know what's in it. The only thing you can do with an opaque type, as far as I know, is add expose functions to it. So if we go back to our example here, right? This is now of type optional, and so there is a function on it where I can actually like return something, right? So this is going to return foo, and in case the value is there, it's going to return 500, right? So whatever this thing, so think of it in Rust a bit like an option, right? So it's option none or option something in it, and now we're just dereffing to that thing in it to do something with it. So yeah, so that's what we need to implement. But the first challenge we have in the interpreter as it exists today is, let's actually do this properly. So account dot of 100, right? So if I run this is going to tell me that there is no off on account, right? So let's ignore this bit in container, blah, blah, blah. But so you're like, yeah, well, that's all nice and good. You're trying to invoke a method here named off on the target account, but no such thing exists, right? So why is it that when I do this optional run, that this succeeds? Wait a sec, there is an optional run. No, there is no optional, right? And so the way this works is actually, yeah, qualify name. There is inside the Go interpreter a function that's called toQualifiedName inside the container thing. And so what this guy does, let me find where that's being used. There is something in the interpreter. Well, if only, right? So check the select. I think that one probably does it, right? Let me check if I'm looking at the right thing. So before traversing down the tree, try to interpret as qualified name, right? So when this, again, let me go back to the browser here. When I have this optional off 100, this is not a select of on target optional, right? This is actually, let me get rid of all this nonsense here about, oops, sorry, optional. This actually is the name of the function. This is actually the name of the function itself. Like we're calling a function that's called optional off. So I can actually prove this to you, because if we go back to our optional off, right? Optional off, right? So if we go here, here it is, right? So create a new optional type T with a with a value where any is considered valid, right? So what is this doing? It's declaring a function that is called optional off, right? And that thing, right? So this overload, like one example, optional of 1, right, will then call into this guy here, types optional off. So that is what we're aiming at implementing. The problem is that this function that we saw, like this call here, to qualified name, is something that today we don't support in Rust, inside the Rust interpreter, right? So I think the way that I propose we go about this is we actually write a very simple test case for this. So to prove, like to showcase like what is lacking, where it fails, and how we can then fix it. So, all right. Let's first start by git checkout -b optional. All right, so now we have a branch to work off, straight out of main, close all tabs. So where are we gonna put this guy? I don't even know where. Because we have, oh no, that's not what we want. Is this what we want? Yeah, that's what we want, right? So what we want is to be able to create an opaque here, and that opaque needs to be, we're trying to implement this guy here effectively, right? So let's first try to get that working. So where is opaque? It's all inside object. Okay, I don't like this too much. How should we do this? Where is, let's see what our friends at Google did. So we have optional here, and that sits where? Everything's always so flat and in types. Well, that looks like a nice place for that. So I think inside our Rust here, I think I have inside common, I have types in here. And so in here, I have all the other types, which are the actual types to eventually be used that I don't think are used as of now. So maybe, oh, look at that. We have optional here. Optional new opaque. Wait a sec. I worked on stuff, so it seems. Why is this sometimes working and other times not? Okay. Oh, because nothing works here anymore. That's great. I think that my VI plugin is very much broken on the latest stuff here, because I'm having non-stop issues. This is my Linux machine, and right now that doesn't work anymore for reasons I don't know. Oh, look at that. Some of it works and some others don't. Okay. That's annoying. And then what else? Yeah, on my Mac, it's a complete disaster. Like, the thing works, then stops working, and whatever. Right. So, how do we best do that? This is annoying if I cannot use this guy. Okay, so we have optional here. It says optional type, new opaque type. The thing is, none of this will actually work as of now. So that was probably a huge mistake on my end. Like I prepared where I wanted to take the type system inside the interpreter. And I guess I shouldn't have done that. It was probably a mistake. That is, yeah, me being stupid, I guess. So, where do we put the optional in the meantime? It should be this guy here, but we cannot use this guy because none of this magic actually works as of now. So let me explain what I'm saying here. If you go to the resolve in objects, right? So this function, this returns like still today a value, one of those enum instances here. So that's what we need to work with, not the other stuff. So because everything's declared in here anyways, I guess I may just as well declare it in here just as much. Right? Let's do that. Okay. So what we want is a struct that's optional value. Okay, let's go value. And it's going to be an option of a value. Right? That's what we want. I want to implement opaque for optional value. That's going to return optional type. And apparently there is more. All right, the equal. No, that's not what we want. Yeah, so that's good. That's fine. And then what we want is opaque equal and as debug that need to be implemented. Debug self. Is it not as debug? Oh, okay, because that's that. Okay. Ah, God damn it. Like, this is going to be annoying. Like, I cannot navigate my thing properly. Sorry, did we extend it or how did we do it? Let's actually go check how I did that last time in my struct. Oh yeah, because okay, now I remember how we did that. So we don't need to do it that way because we can cheat. Okay, so where were we? Here we are, where it's all red. We don't need none of that. Right, and now what we can do here is derive. Oh. God damn it. Like, this is gonna be annoying. Derive, debug, and equal, I think, and partial. Don't go too crazy. What am I missing? I thought I implemented the magic for all of those. Debug, equal, and partial equal. And that, oh, and we can, yeah, we can have serialize as well here. Well, actually, no, I don't want serialize. Do I want serialize? What do you think? Maybe. Not sure I'm supposed to understand that exquis arrête de râler, but arrête de râler. Oh yeah, obviously, we don't want that. There we go. So optional, and now that has the option value in it. Mais quelques lettres paye. Shit. Somebody has, quelqu'un a plein d'emoji custom. Nice. Okay, so optional values, so that's all nice and good. Actually, I think, let's go back quickly to our guy here. And there is another function that's interesting for us, I think, possibly, because we could start with is there not, like, how do I create an option of nothing? Optional none. Okay, so that's this guy here, and it's optional none. Okay, let's try it quickly in our optional. Oh, God. Dang. None. So if we run this, this returns null. Equals null. That should not work. That returns false because it takes anything in. Interesting. I'll have to check why that is that way. But doesn't really matter. What matters here, and is that optional none. Oops. Not none. So if we run that, that is true. Okay, cool. Well, I guess it makes sense, right? Because optional off. It's just surprising the change in behavior, right? So just to be clear about what I'm, whoops. Right? If we do that, we get a no such overload because equal is not implemented for those types. If I do this and I run this, oh, okay. So there is an overload implemented for null, or null is treated somehow in a specific way. So that's what's going on. Okay, so whatever. Point being that we need a way to effectively evaluate this and have this return a opaque value of type optional type with none as its value, right? So that's the beauty of this, is we can implement optional value here, and we'll say pub fn none, which returns self and returns that, right? So that's what we needed. So now we need to wire this function inside optional.none somehow. So that's going to get somewhat messy here. What do we have as a testing playground here? Did I write opaque equal? Okay. So let's add more fun stuff here. Okay, whatever. Test. So test optional, test optional. Well, we can create like one large thing that does that, right? So what we need is to build a program compile optional.none that All right, what does optional compile return? Yeah, results. So we, oh, okay. Expect must compile. And now what we want is to make sure that p dot execute context, we don't need nothing here, default, wait a sec, I'm lost in my parentheses, expect must execute, and that should be a opaque, yeah, so let's do this like this. This should return the value opaque arc new optional value none, right? Yeah, so that's an ampersand here probably. All right, so you know what, let's cargo format this so that we see what's going on. Right, so that's our little program now, right? So this must compile, we execute the program, we don't need like any state to run that program. This must execute, this should not return an error. You know what, we're gonna do this slightly differently. I know it's gonna be a little bit of a mouthful, but I think I like this better. Yes, so we execute this and that should return an OK of a value opaque that's blah, 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 which is none, right? So let's run that. And that's gonna fail. That failed. So why did it fail? Because of the undeclared reference null. So that's interesting because that's not what it should. Foo none. I think the error message itself is wrong, but like at this stage, I don't. Oh, I've been writing code this entire time and you could not see it. But so whatever. Let's run this. Right. So this should have failed because of the undeclared reference and then the undeclared reference to none on that thing, right? So that's what we wanted. But here is what we get. So we wrote this again. This is the test that we wrote, right? So this test creates a program, right, of optional none and runs that here. That's the execute here. Context, we don't need any state. And that should return an OK value opaque pointing to an optional value none. But that's absolutely not what we're getting here, right? As you can see, this fails because it says that undeclared reference none. And the reason being that we're trying to resolve none on optional, and that is wrong. So where did that happen? Now we don't care, that possibly we don't care either. Okay, that's great. Yeah, obviously, that makes sense. Okay, so where does that happen inside our interpreter? That's the question now. So what it calls underneath is this resolve method, right? And something will try to resolve that thing. That should be a drum roll. What was it? I think that should be a, sorry, this is like really like a large piece of code here, right? So, oh yeah, I think it should be this, right? And that's where it goes, oh, like how many arcs do we have? And then tries to figure things out here. I think in this particular case, we shouldn't bother ourselves with that. Right? And I think here we get here, and that should be this here. Or else, you know what? I'm just gonna panic here. Lol. Right? So I think if we rerun this test now, I think it's gonna panic, right? Lol. There you go. Lol. So we're here, and that's what's happening. So there's a few things now that are happening here. So one, it doesn't find the function. That comes to no surprise because nothing has declared that. But more importantly, so let's rerun this without the panic so that we really see what's going on, right? It's complaining about the undeclared reference none, right? Here, this blah, blah, blah thing. But that is not the name that it's supposed to search for. It's supposed to search for... Go here, and now we search what is to qualified name here, right? It's supposed to search for this. So find usages again. Let's see where that is actually being used. The check call, right? So there you go. It goes if there is a target. So let's see, right? I think, yeah, so let's read this. I read that code but a while back. So I think target here, target here, no, again, if receiver is target present. So I think something above makes as call. Okay, gets the function name, that's great. Do all the stuff that we need to do. These are things that we will need to implement, right? It's that magic. But we're not there yet, so somebody else's problem. The best kind of problems. All right, call is member function. If it's not a member function. And member function is the thing that will, I think, if I remember right, make sure that the target is member, and is member is when we have a target, right? If it's not as member, so right. And so this goes, right? So this is, oh, that's a static call to a simple name thingy. Which is actually what we're doing, but we're guessing wrong because it thinks there is a target, but there is no target, right? So it needs to be flattened out, become this qualified, could it be qualified? So how does that work? This goes into, is the target an ident or a select indeed? Yes, that's going to be interesting because that's the recursion case. Just to be clear, what this guy concerns itself with is for, let's say, nested namespacing. So we could ignore this for now. We can only, I think, focus on this one. But just to be clear, I'm going to go here. What it's trying to concern itself with is so that's what we're looking at, right? So that's easy enough. But it could be, I don't know, namespace dot, right? So now it's sort of a composed thing, right? So this, even though we invoke none on optional itself now is a select kind, not an ident. So that's the ident case. And like this, that is the select kind case. So back to what we're saying, this would be ns.optional dot whatever, right? And that's for the simple case where it's optional dot, right? So that's what we do. The target here, E would be of type ident, and then we get the ID out, and then we say that is the prefix and that is true. So, okay, awesome, great. Then let's go back to where we came from. So that has the qualified prefix. It rebundles the entire thing back together. Maybe qualified name does that as a lookup first. And if that fails, then we fall back to the code that we had before. So it's effectively this here that we're missing, this if condition that we're missing in our code in Rust. So let's go here and let's try to do this. So, right? See, that's the function, that's the name. Okay, as str, interesting, because yeah, we do the lookup as an str, that makes sense. So what we need to check is this call, oh, look here, it's this call here, right? So, okay, so what is this? That's an option. If let sum, yeah, I'm gonna call it target equals call dot target, right? So, oh, you know what? We can be very evil. We can do this twofold. We can't we? No, we cannot, because it's a, okay. If, can we? Can I match directly on this guy here? No, I cannot. Now I need to match if, oh wait, oh, because that's deconstructing. So what do we have here? Call is that. Yeah, I probably need that. Now we need, so we have a target. If target dot expression, how does this matches thing work again? If matches, I never know how that one works. Well, you know what? I'm just match target dot expression. So what we care about here is the ident case. Sorry, what is this again? X ident prefix, right? Or yeah, I'm just gonna call it prefix for now, right? Then this let's func equals. Can we do that? Probably not. Yeah, we'll need to fall back anyways, right? Anyways, we'll see that later. Okay, then in which case, what is it that we need to do in that case? What is it that we need to do in that case? ctx.get function, and what we need to do is format this guy with prefix dot yeah, can't do that obviously, so that's a bit of a call dot func name. What is func name? So that would be none in that case. So let fun, oh, let fun equals, right? So now we possibly already have a function there. Let's call it func, just as much as the one below. So now, in case that didn't resolve, Wait a sec. Yeah, that becomes none too. That sucks a little bit as code. Now we can go func unwrap or else like that, right? Why didn't that work? Because I need to do it that way? Yes. Okay, so now technically, oh no, I'm wrong. Sorry, where is this error returning? That should be fine, should it not? Can I not do that? Very obviously the answer is no, but I thought I could. Right, expected, but found the result, so that's our problem. Right. Okay. Because this guy forces me to return the pro things. Can I just do that? No, I cannot, huh? Actually, I'm an idiot because I can do that. No, I cannot do that either. Darn. Okay, that's not a problem. We'll do the explicit way for now. It doesn't really matter. Right. So we have our function here, and that's the call that actually we want to make, right? So let's panic here. Panic. Looking. Let's escape. That becomes qualified name. Panic. No qualified name in function found. That's what we want. Not that. Now we can remove because it's not. So that's complaining because we're not using that, guys. So that's fine. Oh no, it is complaining because of what? All right, because it doesn't know what thing that is. Do I? Yeah, I needed whatever, right? Okay, so that's gonna be an option and function. Then import it, that's fine. Okay, so if we rerun this test, yeah, we don't care about that. So that failed because see, now we're doing the no optional non-function found. So that's great. So that's what we wanted. So we're catching the thing at the proper level. And now we need to look up for that thing. And so in case, what we'll do is match func. And wait, what did I do here? All right. What we want is match func. Sum, you return that. None. We do this inside dance here. and that should be fine. So can we rerun this? It's still gonna fail. Undeclared none. Right, so we're back to square one, but now, so let's go format our code so that is somewhat readable. Right, so now we're at least trying to solve that. I don't think I can match on those two things in one go, can I? That'd be great. Like, I don't like this code here. Wait, let's ask Clippy. Yeah, Clippy's happy. That sucks. Okay, whatever. Let's say that's fine. So now what we'll do is we'll make it so that optional dot none actually returns like is wired to our optional none function, right? So actually what we need to go for doing those things is going to our context. In our context, the default one I think is the one, yes. There you go, right? So what we need is ctx.add function, and now the function is optional.none, and that should return trait objects. Oh, did I do something wrong? Why is this not visible? We didn't do that, did we not? Did we not write a code? Pretty sure we wrote the code. So yeah, but we didn't make this public, so that's annoying. Pub, and none is now there. Okay, so if we go back here, optional value none. Why is this not correct? Oh yeah, because that's the entire thing with the function context and whatever. Not everything is as great as what we would want it to be, huh? So here is the trick, is that this is the way this works. So actually what we could do is cheat somehow. Well, not cheat, but like, let's declare this as that, right? Functions, colon, optional, none. And that's read the glue code, right? So if we go here, that's going to create a bit of a weirdo thingy. So that becomes optional none. And what we want is that to return optional value colon none inside a value colon opaque arc. That is sad. In case it's not obvious, what I find really sad in this case is that we'll create a new none arced all the time. Like for no really, like those arcs really annoy me, period. Actually, I'm gonna be very honest. Like I hope that one day we get to clear all that stuff up, but do we actually need to make sure that this, yeah, technically this is wrong because this should be not that. Do I need this every time? Like, because that's an into function, right? So let's have a quick look at what the function trait looks like. The function trait, function context, that's all we need, right? Oh man. So we don't need this, I think. And here, that's, wait, oh, okay. If ftx dot this is sum, or ftx dot args not as empty, then this would be like this, right? So I don't know whether that's great, but so what we're doing there is making sure that like it's not called on the target and that it's not passed any arguments, right? Hello, is this Haskell? No, it's it's Rust code. Yeah, Rust code, Rust interpreter, like an interpreter for a language called cel, C-E-L, implemented in Rust. Yeah, not everything is Haskell. Maybe everything should be Haskell though. I don't know. But I can see how this could look a little bit like it. Maybe. We'll never know. All right, so let's rerun our test now and see what happens. So if we run this, did we succeed? We didn't. That's annoying. What did we forget? It's still complaining about navigating to the target. Oh, yes, I think I know why. And that's probably because of this here. And we cannot change that. And we get to this guy here, and it says, oh, there is a target, and now it's trying to resolve this guy here, right? Prolog would be another good option. Yeah, maybe we should stop with all those fancy new languages. I hate that people are finally realizing that non-Turing completeness is useful. Oh yeah, it's useful. So are you ice cold witch? Are you making that statement because you just looked up what cel is? And that it says it's a non-Turing complete expression language? Yeah. No, it is very, 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 very useful to have yeah, maybe I should. Do you guys want me to have a quick look at what cel is and give it some context here? Yeah, well, isn't that what programming is all about? We're making Turing complete text files. I'll let you ponder that. Famous last words. Now, yeah, I'm very, very, very much, I really need this whole thing. So yeah, maybe I can do that quickly, right? So the reason, okay, so let me switch back to my browser here, and let me switch back to cel.dev, which is where you can read upon what cel is, right, to begin with. So again, cel is a non-Turing complete language. It actually comes with a bunch of nice features. It has many traits that we care about. Like when I say we, it's the project that I work on, right? So because this is effectively my side hustle, if it makes any sense. Like, so I work at Red Hat where I do let's call it cloud stuff. And actually, cell is pretty much used in the Kubernetes space because it lets you express things in a lot, hopefully in a somewhat easy way for people to understand. So if you go to the cell playground, that's playcell.undistro.io. This comes with, so here on the right hand side, we have some input that will automatically be. So that's one property of cell. Like it integrates with JSON and YAML and protobuf seamlessly, let's say, for as much as you can seamlessly integrate with JSON numbers. So let me give you an example, right? So and we mostly use it for data retrieval and predicates, i.e., let's take this example, right? If balance is superior or equal to transaction dot withdrawal, right? So I can run this and this says false, right? Because the payload that was passed to this expression says, oh, you only have 500 in your account balance and you're trying to withdraw 500. Well, that's not going to work. So you can see you can write more complex stuff if, let's say, you have overdraft protection and so forth, but not the point right now. So what's interesting here is, so what happens underneath? So there's a few things that I think are interesting here is there is this cost model associated with an expression so that I can actually create, I can say that I'm willing to accept cell expressions that at most costs this much, right? So let's say in this case, 5, so this one would be accepted. But if I would then make it like more complex and I don't know, I think because they run the optimizer, I think if I do this, the cost is not going to change. Yeah, exactly. Crap. And I don't know, let's do something stupid, right? Has account balance. Yeah, this is all optimized away. Annoying. Bad examples. And let's say do this, right? Why is this? Oh, because it can optimize it away from there as well. That's annoying. Let's do math then. That should change it. That's not changing it either. Why is that not changing? Interesting. Yeah, there we go. That'd be really cool for CRUD-like APIs with filters. Oh, that's interesting that you mentioned this. There is, I think, I actually never looked into it, where somebody actually uses cell in order to do database queries, and actually they use R interpreter, i.e. the cel-rust interpreter, to do those things. So forward center, I guess. Yes, it seems to be a thing. Actually, if you go to the crates.io, maybe it's not a public. I don't know if it's a public. Nothing jumps to me right now as being that. Though arguably maybe it's a dependency of the old, because we changed where we publishing this. So if you go to the, you know what, maybe only the parser is actually. No, okay, so I don't know, but if you go to the project on GitHub, cel-rust, and you search through the issues, somebody at probably a closed window, hopefully. Um, SQL? Maybe that person? I don't know. Anyways, all that to say, somebody is doing something around those lines. Yes. But I don't know who. Like somebody who uses this project, but I don't know who that is. It's used quite a bit in Kubernetes to be able to specify advanced constraints on certain things and whatnot, right? Like you get a full-blown query language. But the thing I wanted to cover is actually something slightly different. And that is this bit here that I find very interesting. So the way that cell is meant to work is this cost model that you saw is associated with the expression itself. And so back to ice cold, which I think now to answer why I think the ST was the cost that you see was probably the cost of the actual expression evaluation. It's not the worst case for this expression. And I think this is why we didn't see that. And it's stuck to being 5 because indeed, as you say, it would sort of ignore that, right? So, but what we care about, let's say in a Kubernetes environment, is that I can know that this expression will at most cost so much. Am I willing to accept this cost in the context of where I plan to evaluate this expression, right? So, and the way this works now is I can make sure here, right? I get an expression, I can parse it, make sure that it parses, I can check for it, make sure that it's safe. So example, given that I'm not trying to compare an integer value to a string value, because even though this seamlessly integrates with YAML and JSON and all this nonsense, values like, and it does have regular expression, yes. You go like, okay, so what do we do here now, right? Do we accept this thing? And when we accept it, we want to be able on the control, like on the data plane, which is literally where, like my project is mostly using cell for, inside a proxy to be able to very, very, very quickly know, do we accept this, yes or no? Yeah. You can, like, I think they have a cost model on the regular expression because it depends on the type of regular expression that you accept anyways, right? So we can sort of know things more or less. And then again, you can also decide to not accept regex if you don't want to, right? And then provide better alternatives, for instance. And we'll talk about that in a sec as well. But yeah, so the idea is that you validate all your constraints up front, you store the stuff, this AST now somewhere, and now whenever you need to evaluate it, you can make sure that your expression is not going to be too costly, it's not going to fail randomly because, I don't know, something isn't right or whatever, right? So that's the idea. Type annotation, it has, okay, I'm going to say generics, but it's not true, neither. It means, yeah, so like container types are genericized, if that makes sense, that you get. And then you can, is it portable? No. So on the ST representation, that's the whole point. It's meant to be portable. So the way that it's meant to be portable is that there is an agreed upon set of nodes in your AST, right? And they have a spec protobuf representation for those nodes. So the one, but it's a mapping. So it's not like the AST itself uses the protobuf types. Instead, they have protobuf types that you then to or from proto, if that makes sense, to transform the AST back and forth. And then, yeah, again, there's a bunch of optimization passes you can do on the AST itself. You can do AST transformations that could benefit your use case. Yes, Protobuf, this is Google. So Cell is actually a Google project, but they only provide Cell interpreters or runtimes or like the entire shebang for, guess what, Golang, Java, and C++. I'm going to be honest, for what I've read on the C++ run, like I wasn't too sure. So yeah, but they don't provide a Rust one. So that's why, so the way that we arrived to using Cell was because one, we run inside like cluster environments. So Cell was sort of the de facto, or becoming the de facto standard over there. But all the low latency stuff that we do it in Rust. So that means like a rate limiting service, for instance, that we implement is written in Rust and needs to evaluate cell expressions. But that's sort of the good news for us here, right? If you can, like, if we can have the cell validated on the Golang side, we can inject the DST back into our Rust runtimes directly. And then there is the code that we run inside the proxy is run inside a WASM runtime, inside Envoy. And same thing again, all the code there is Rust code. And that's why I got involved about a year ago in the cel-rust project here, right? That tries to bridge that gap, if it makes sense, right? So this project is not it's not a Google project. It's not even a Red Hat project. It's just me as a Red Hat employee that uses this. That's the beauty of working for an open source company, is that part of my mandate is actually try to make open source better. And we're users of that. We're an advanced user of that. And as such, I get to contribute, well, as you can see, to contribute on this. That's my face here, on this project, right? There is already sort of, well, for, Ice Cold Witch, you need to be more precise there in what you mean, like serialization of what? I'm not sure I understand the question. Because there is support for Surday already, in the sense that the values that come in and out are serializable, deserializable, depending on whether they come in and out, through Surday. So the answer to that would be a yes. Now, if you're talking about the Surday serialization for the AST specifically, there's no reason not to do it. Yeah. So, anyways, that's what we're doing. Be nice. Anyways, okay, so that is that, I guess. Yeah, and just then to maybe re-give some context of the stuff that I'm doing here, is I'm trying to support a thing called like optionals in yeah. So on the EST Surday support, yes, I guess it would be for projects that want to use cel-rust, period, if that makes sense. I don't know if there is Surday protobuf automagic stuff, but if you want the interop, right, you will probably want the protobuf support over like directly, right? Okay, so what I'm trying to implement is a feature that currently misses from the from the interpreter, and that is this. So I rewrote the parser a few months ago to use the proper grammar, the antler grammar. So if your antler stuff, there is now an antler for Rust crate, and I probably still need to open a PR against Antler to provide proper Rust support as a runtime for them to use. Right now, you would need to use the Antler for Rust jar yourself. But anyways, so as part of that, in the grammar, there is support for this notation here, that if we run this, you will see that it returns 500. Effectively, what this does is trying to be lenient with regards to versus failing, right? So if I write this like this, because of the guarantees that Cel is trying to provide, we need, so in this case, right, we want to be sure that, for instance, balance exists as a field on account, right? So there are ways for you to specify all that stuff so that the expression can know that there's going to be an account thing, like binding, variable binding, and then what the type of that binding is. And that can be a struct, like even like a protobuf message right away. And so we know exactly what it looks like, right? And I can validate that exists. But sometimes you don't know if something's going to be there. So let's do this, right? So you want to be able to say, all right, maybe the balance is there, maybe it's not. The way you would have to do this without this is like this: has account.balance, right? This is simply testing whether this field exists. In case it exists, you return balance. And if it doesn't, you return 0, right? So if I run this, it's going to return 500. If I run, like I rename the field balance, now it returns 0. But that is a very crappy user experience, right? So the way to fix that is like this: balance, right? So this is now returning null, but it's actually not returning null. Again, I can do it like that. And actually, I can even fix it here, balance, right? So the field is there. And if I do this, it's going to tell you there is no overload for the operator greater than applied to left-hand side being an optional din, and on the right-hand side an int. So actually what account.balance returns is what's called like an optional value, like an optional type. Think of it like option in Rust actually, right? So some 500 is not equal or greater than 500, right? So you need to sort of unwrap this. And so the way to do it, one way of doing it is like this. So now what I'm saying is if there is no balance, right, I'll return the value 0, otherwise use the value set inside balance, right? So if run this now, this works, let's say over 100, right? So this works because this is effectively unwrap or I guess, in Rust, if that makes sense, right? That this would be the equivalent of that. And that's a much nicer syntax for people to use than you can, because all of that becomes sort of nestable, right? I can keep on going like this. It makes for a much nicer, yeah. Exactly. You don't want to give, actually, that's a very good point, right? There is no unwrap here. Like it cannot unwrap. I cannot say I expect the value to be there. Well, actually, the way you would do this is like this, right? Not going to the optional type. But if I do, right? Now I can do this, and it's going to return null. But I cannot deref null, really, right? I cannot go like unwrap here. That's not a thing. I can only do things where I remap it to something that's meaningful, right? And yeah, so don't use unwrap in production code if you can avoid it. There is actually a lint for that, and Clippy will not allow you to have unwrap in your code. So yeah, don't unwrap. Like panicking is never a good outcome. Or, well, okay, let's not say ever, but probably not the one you want. Let me put it that way. So that's what we're looking at implementing. And the way that it's implemented is using what's called an opaque type, actually. So the optional value is of type opaque, which means that we cannot peek into it, right? You cannot deconstruct it or reach for fields or anything like that. The only thing you can do is call functions on an opaque type. And yeah, so that's what we're doing here. And that's what I am trying to do here slowly. And yeah, so by introducing this optional value inside an opaque value and so forth, and make those things work. Yeah. So the one thing we're doing right now is this. So the way you create an optional dot none is like this, right? So this returns null. So this created an optional none. The trick here is that this is not a call to a member function none on optional. It's actually a call to a function that's called optional.none. And the interpreter, as we have it today in Rust, doesn't support that. And so that's where I am right now. So the code is here, right? So I'm going to redo what we had before. I'm going to panic here. See, I said it's never good to panic unless when I want to. Qualified name possibly found, right? Let's ignore this. So if we run the test at the very bottom of this file here, that effectively tries to do what we're saying, right? A program that simply like returns an optional none. But what we had is that it would say, I couldn't find optional, right? And obviously then as such no function none. So I had to change this so that it becomes like it says, oh, I possibly found a fully qualified function name, whatever we would want to call this. And so I did that, at least for one case. But the interpreter then backstabs me right afterwards. So, right? So as you can see, that's what we're getting, right? Possibly we found a fully qualified name. Is this an actual fully qualified name? And then what needs to happen is this. So this returns like some function in this case. The problem is that if this is the function that gets returned, the call to target here is still there, because that's how we decide to then either resolve, right? So I cannot do what I was doing, or I need to do it in a very crappy way, and I don't like this. But it's actually, you know what I can do is call this qualified function. And get rid of this again. Is this correct? Interesting. So what was the initial code? It was func blah blah blah. Oh yeah, because we need to get rid of this, I guess. No. What? Oh no. Wait, what? So we get the function, otherwise we do this, and why can't we do this? Okay, you know what? I'm just gonna cheat quickly. Delete all that code. Take my qualified one. Take the thing back here, whatever this was, and re-add my qualified function in. Okay, so now what we need to do is actually do two things, I guess. In the case there is a target. Oh, wait a sec. Yeah. No, that's wrong again. Crap. Okay, let me explain what's going on in my brain here. Like, we need, like, yeah. We can do this in one of two ways, I guess. We can say, yeah, we want to, that's annoying. I don't know, like, I'm trying to not mix too many concerns here, but effectively, if this succeeded, we don't care about this anymore, right? None of this stuff matters. If we found a qualified function, then it's a qualified function, and we go straight into this effectively. Is what we need to do. Create the function context, and then that's it, right? There's no need to resolve the target thing. So, and otherwise we go in here. So this needs to change completely. I'm unsure to best express that. Maybe I shouldn't focus too much on how I express it and just get it working for now. Maybe that would be a good start. Working code, I've heard it can be good. And then we can look in making it beautiful afterwards. So let's do that, in which case. So all of that goes away, actually. If called target, if there is a target, so we're back to this code here, right? So actually that's what needs to change. Yes, I got it. If this, then that. Six, we don't even need the 6 lines here. So this code here is not where we want it to be. We want it to be, and get the function, yes. So yes, what is it? Target, that's great. We named it right. So if there is a target, we want to check if there is a, how do we call it? Let qualified func equals, right? Match qualified func. So in the case it's none, we didn't find anything, then we want to do this. But we need to resolve the function. And now, so, sorry, match qualified func, yeah, and func, and same thing here, oops. Do resolve the function, but if there was a function, func, oops, same thing again. What is it? Right, I think that fixes it. So let's rerun our test and see if I'm, oh yeah, that goes away. All that we don't need anymore. And now let's rerun the test, and that still fails because what? Value none, left undeclared reference optional. So we're still not good. Okay, so let's think this thing over. If there is a target, we first want to make sure that this is not maybe a qualified thing. And then we get a qualified function. If it's not the qualified function, so that's actually really easy because it says optional, so it's the target. So what uses the target still? Oh, there we go. None, right? Oh. Sorry, how does, wait. Oh, no, that's correct. It's the func here. That's wrong. New function, none, right? Let's rerun this. And bang, it passed. There we go. We now have support for functions that are qualified. That's not bad. That's not bad at all. Okay, so that's step one. So maybe we want to have a quick look at what we've done. So we've added this function. That's, I think, all we changed in this file. Let's, okay, this is going to be very horrible to read. Get status, right? So get diff. So what did we change, right? So inside functions, we indeed only added this new function, optional none, that just goes, oh, is it the proper thing? I don't know that the error that we're returning there is really the one we want, in case somebody like adds stuff to this. Then what else? We created the optional value and implemented the opaque for optional value so that it's of optional type. That's what we wanted. And then we fixed the function resolving code to actually try to first check if that's a qualified function and then invoke it in case that's what we want. And then we wrote a test for that. Well, that sounds good. Feature optional. You know what? I'm gonna make this like a long message. Feature optional. Basic initial support. So what did we do? We allow for qualified function names and dispatching. Created optional value to be used within a value opaque. What else? And added support for optional none function call. Right? That's what we did. So with that in mind, you know what? Older cargo FMT, I didn't do that. That was stupid. Cargo Clippy, all features. Git status. Darn. Amend this thing. All right. And then what else? Yeah, let's test this nonsense. Like everything. What I'm thinking is opening a draft PR already with that word git push origin optional. Oh, that's annoying. How can this be? Wait. Oh, yeah. I know. Git push Alex. Optional. Oh, I had started something there already. That's annoying. Git push. You know what? I'm gonna git branch dash move optional draft. That's fine. I don't know what the remote branch is, and I don't want to investigate this right now. All right, and let's create a new pull request for this. Obviously, it opens it in the wrong place. So you go away, you go here. That's darn. Like I've been coding away forever, sharing the wrong screen, and nobody said anything. You like awesome. Whatever. The code's there, it works. Just trust me. Famous last words. Okay, so again, what we did, we have support for this, and all of this stuff works. And I'll create a draft here, mostly as a heads up and more examples of using opaques. Missing are, what are we missing? We're missing all optional functions, and we're missing enabling optional syntax in the parse. Well, actually in the parser it is there. In enabling optional syntax. Oh, is it? No, I think there is work that needs to be done in the parser because we need to create the optionals when the optional syntax is used. So, well, we do know that I think right now it errs out. Maybe make use, I guess. Make use of the optional, how do we call it? Optional value or optional value? Value in the parser. And then what else? And then that's it, I guess, right? Do we miss anything else? If we have all the functions, and no, I don't think we missed anything else. It's actually not that much work. And draft this pull request. There you go. All right. That is not too bad as a thing. Yeah. Good, good. Well, let's go back to our coding. Let's yeah, I don't know if optional is going to become like a feature, or because it, like in the Go interpreter, it's also something that you can turn off and say, I don't want to be supporting that. So I don't know if you want to do this conditionally inside the cell interpreter here as well. I would be tempted to say yes, because I like the feature parity with what's it called, with the other interpreters, right? So that you can actually again, as I said, like have the code portable and all those things, right? I think that's nice. So yeah, so I wouldn't want to break that necessarily, but yeah, what else? Yeah, there's quite a few, I think. If I go to our friend here, and if we go back wherever we came from, right? So what are we getting? We're getting those. Oh, look at that! I lied. There is an optional unwrap. Interesting. That doesn't look like a good idea. What was that? Converts list of optional values to, oh, it's only for list. Interesting. Okay. Yeah, indeed. So if I have an optional none, like, oh, yeah, okay. Unwrap. That's yeah, maybe I wouldn't have named it like that, but whatever. Then what else do we have here? Yeah. Wait a sec. What was this guy then? What? Which things? I clicked that then. Oh, okay. Okay. Sorry, my bad. Same thing. So that's the member function. Sorry. Which one was it? Yeah, this one's the member function, and that is the function. So that you have both notations. Oh, I don't like this too much because what we have right now, we don't have. So if you go to the cell interpreter, there is an issue here that I created. It's called support proper overloads, because this one explains it, right? You should be able to implement this. I overload the method, or the function as we call it here, size on as a member function on an integer value. But what we only have, like, I'm not sure how to say it, like simple naming and resolution or whatever. So size can only exist as a single declaration, function declaration. And that's bad, because now you will never be able to implement this, right? When you do this, you're not adding the function, you're setting the function size to this call site. So now, obviously, this call site could now deal with like all the possible things, right? Because that's the way we do it. Anyways, so if you go here and we go to size and functions, right? There you go, right? So what am I being called on, right? We go like, oh, it's a thing, and then we do dynamic dispatching, if that makes sense, right? As part of this. And that's not too bad until you end up in a place where like the best thing you can do is add like support for another value here, like let's say I64 on your function call, and then if it's not the one you expect, you call into this guy, this size, right? Or you duplicate all that. The problem is this isn't composable, right? If I want, like, if size exists in a standard library and user A wants to add size and I want to add size, like this other user and myself, we need to coordinate now on how to make that happen. Even though maybe they add size on, and that's what I was getting at, that's what makes me sad that we may need to add way, like, this is getting busy quite a bit, right? So it's like we keep on raising the chances for collisions, and now somebody wants to, like, I don't know, implement a method and they cannot do it, right? The good news is they can do this for functions, obviously, but not for member calls, right? Because now, right, you cannot have a function qualified with a target. That's not possible, which is a good thing, right? Otherwise the language would be unreadable, right? How do I know that when examples say you write foo.bar.baz.boo, right? What is what is the target and what is the function, right? That starts, maybe I'm navigating to the field bar inside foo, right? And then calling the function that's called baz-boo on it. But maybe no, maybe I'm calling bar baz-boo on foo, right? Like, it gets confusing as fuck. Sorry for the kids listening. Foo.bar, like, it can only be a fully qualified function name, which is foo bar baz-boo, and then maybe takes args or whatever. So that's sort of clear enough, I think. But so what am I trying to drive home as a point with that? Yeah, is that without proper overloads, it just feels clunky, right? We're keep on closing more and more doors. How do I know that there isn't somebody out there that already has the example given optional or value function, right? Like that goes, because that is not registered to that, obviously that's registered to that. So if anybody already has or value and they upgrade the library, bang, like conflict and all that stuff breaks. So the good news is if we do this with a feature flag that, let's say, by default is not even enabled for now, we disable it for now, at least nobody would be surprised, right? Like, especially as this is a silent killer, right? Oh, wait a sec. No, it's not a silent killer. I'm lying. Because if they have or value, they will simply override what we have today and the stuff will not work. So it's not too bad. Anyways, I'm a bit unsettled here. I think I'm going to make this a slightly shorter stream today. I'm going to be very honest. It's not even noon here, but I'm hungry. That's bad. That's one. But then beyond that, I think the draft PR that's open now, right? So if anybody wants to go and have a look at it, which is this PR here, right? Like everything's there, right? The rest, oh no, sorry. Maybe making use in the parser is not obvious. So maybe I can cover quickly some of that. So somewhere, now I need to refresh my mind because I haven't touched that code in months. So the parser here somewhere has, oops, undo. Right, here we are. So here, right? Like it's effectively all those unsupported syntax, right? So if it's an optional field, right? Here, what we need to do is not return this error right away. What we need to do is say, all right, is the feature enabled? If the feature is enabled, then we create an optional, well, an opaque value out of that thing with either null in it, i.e. none, or the value of the thing that you're targeting, right? Depending on what we're doing here. So here it's a field initializer list, apparently. So what does that do? Huh, that's a good one. I don't even know what this means linguistically, like from a syntax perspective on that one. So, oh, wait, is it just if, oh yeah, because it's an ident? Okay, field name. Oh yeah, because we're possibly trying, okay. It's if we're trying to initialize a list with an item in it that had like, okay, let me do this here. If we're trying to initialize a list like so, right? I think that is it. So that returns a list of 0 because we don't have the thing in here. If we do that, that returns supposedly a list of 500, which is wrong because actually what we want to do is, what did they call it again? Opt? Is that thing what we're supposed to call? Okay, looks like I'm wrong. Or is this maybe not always enabled? No, that's supposed to work. Interesting. Unwrap opt. Okay, that doesn't work. Yeah, there is another thing, like the library has versioning in it. And some things only exist in certain versions. So maybe there is even less work to be done than what I feared. Wait a sec. Optional.unwrap would be the other thing. Yeah, and that doesn't exist either. Okay, so that's great. That means that it's not always there. Yeah, so that's apparently part of lib version 2 or newer, those things. So sorry, I'm reading the Go source code where those things are being defined, right? That was the unwrapped opt. And that is the optional unwrap, right? So if we check, that's all guarded by if lib version is superior, like is greater than or equal to 2. So it looks like this cell playground that we're using there uses an older version of the standard library. Okay, that's fine. So it's actually less functions to implement than what I feared. Though apparently on the optional front, that is it, right? It's those lists first, yeah. So it's only these two. So if we go back to where we came from, right, we still need to do the as value, which returns the Boolean. Oh, the flat map, the map. Okay. At least they're aptly named, right? They're opt map, opt flat map. So it sort of is obvious what is going on. So I like that. Anyways, okay. So I'll leave it at that for today. But plan is then to follow up on this draft PR and implement all the other things. And then the call sites inside the parser code, right? That will just create those values as optionals and whatnot. That should be pretty straightforward, famous last words. That being said, I think one caveat there is that today the EST doesn't really have values, I think. I'm dealing with... what am I dealing with? Yeah, those are the fields, the vec, passing, this will return. Yeah, oh, wait, that's not even one of the functions we care about. Sorry, back to Rust code. Slash, how did I? Dot opt. No, we don't want the initializer list. Those are, I think, functions. Yeah, those we care about. And that's what we care about here. So that returns always, yeah, obviously it selects expression in this case, but here, in case it's that. Oh, yeah, it needs more. Okay, there's a little bit more work to be done here to adapt the parser to do all those things. Maybe that's a good next stream, though. I'm thinking that maybe mid next week or whatever, I might be might be doing a stream. Like, I don't know, like, we still have a few viewers here, like Ice Cold Witch and Forward Center. It was great having you asking questions and stuff. So I don't know where you're located, but what I'm thinking is maybe doing this afternoon time, Eastern time zone. So like Eastern Standard Time. So that'd be, yeah, I guess I would maybe start like 2 hours from now. Something like that next week, maybe on Monday. And I can prepare like all the other functions, so they're all coded, like all that stuff is there. And the only thing that would be missing is like fixing the parser. I think this could be interesting as a subject matter. So I'll prepare that for, let's say, Monday next week. Let me check my calendar quickly. I think my Monday next week is fairly open. Yes, it is. So I think I'll do that. And yeah, and I'll prepare that and then record all that anyways and share that with everyone again. Yeah, that sounds like a plan, I think. Change, because, yeah, I'm doing mornings, so that is more friendly to say people on the East Coast and Europe, but maybe I do one that's friendly to people on the East Coast and West Coast next time. So I'll do that. Anyways, good stuff. We made some progress. We opened the PR. I'm going to leave one last comment here on the PR saying one question that would need answering is, how do we want to enable/disable the optional support? If I remember correctly, it is optional on the parser in other implementations. We could also make it a feature which would then disable registering all functions with the default context. if someone was to use one of these new function names, though, they would override the newly introduced optional ones, though. So think this necessarily matters too much. What do you think, Clark? Comment. Here we go. So try to have answers to those questions so that we can hopefully next week on Monday then implement the entire thing and solve it, like open the PR, right? Like in the proper way. Now, again, I don't think it matters too much if it becomes an option on the parser or a feature or whatever. It's just changing a bunch of if statements somewhere, right? So, and the support for not supporting, if that makes any sense, is already there anyways. Yeah. So that's it, I guess. Well, that was good, short and sweet. Thanks for the questions and whatnot. Good stuff. Thanks again. See you all Monday afternoon.